Before this video begins, I need to clarify something. Throughout this video, I am referring to this droid as SK-62O. That is not the number 0, it is actually the letter O. I should be calling this droid SK-62O. So hey, before the video even starts, we've all learned, I've learned something, and you can just sit back and point and laugh every time I make the mistake. Throughout the video, it is what it is. Let's get to the video. This is a very big box that contains SK-62O. This is a droid that was exclusive to the Galactic Star Cruiser, which was like a 3-day, 2-night hotel experience thing where you could really immerse yourself in the whole galaxy's edge. And unfortunately, it has since closed, and now Disney is selling off all of the extra stock of the merchandise that they used to sell on the Star Cruiser, including these 620 droids, for a lot less than other droids. Which means that a droid that used to cost hundreds of dollars on the secondary market, you can get a brand new one shipped for what it would have cost you to buy one new on the Star Cruiser, which means I have one now. So my plan for this video is pretty simple. I'm just going to unbox it. I want to open it up to confirm my assumptions, which is that this is nothing more than an R2 unit with a custom paint scheme and unique dome. Okay. Whoa, okay. Yeah, we got batteries in the remote. See how that opens up. Personality chip. That door opens up. Did I know that that door opened up before? Yeah, I just double checked my R2. Of course it's there. I don't know what I was thinking. So the paint scheme, I love the paint scheme. I love these sort of metallic blue guards, whatever you want to call them, to cover up the accessory ports. I love the paint scheme. I love the design. I love the way the dome is designed. I mean, there's every reason that I would want a droid like this versus, well, just a regular R2. Does the head come off? Okay, it does. It does come off. Okay, yeah, that looks like your standard R unit top there. Let's see where the lights are going to be. You can see the wires come up through here, over here, so there'll be a light over here. That's the only spot I can see. And then here. And that looks like it should be an LED, and maybe the wires run to it, but I don't see like a specific channel for just the wires going to there. If that's not an LED, that is something that needs to be modified to become an LED. That is something we can take a look at later. Okay, so let's see what we got. Turn you on. Turn you on. Looks like I'm going to have to pair it. We are paired. Let's take a look at where those LEDs are. I only see 2 LEDs. An LED here and an LED here. In any case, that is just begging to become its own LED. So that's a mod that just is going to happen. But for now, I want to take a look at the internals of this. I'm going to pull the dome back off. And we'll continue with the disassembly. Before I continue, I just want to see the beacon that this makes, and so I'll just use my droid toolbox and we'll take a look. And it identifies itself as just a basic R unit. So this is generic. That's fine. There's no custom personality chip for SK. One of the bummers with this is that it didn't come with its own custom personality chip. That is the one big miss, I think, of this droid. I'm going to remove these because while I'm taking the droid apart, I do not want to inadvertently short anything out, which would only happen if power is being delivered to the droid through batteries, so removing them is a crucial step before disassembling. Yep, and all the screws go flying out. Disconnect the battery pack. Let me gather up the remaining screws. Alright, so what do we have inside? We have some leftover masking tape from something. And the board itself. It looks like your standard R-unit logic board. I don't think there's anything new or unique. So if you haven't seen one of these control boards for an R-unit droid before, a brief tour. This little daughter board here contains the Bluetooth controller for the droid. This is the main microcontroller. This is what the remote is connecting to, and this little microcontroller is also what controls the motors for the droid. The daughter board on the back here, this is the audio controller. This is where the sounds are stored. The personality chip connects directly to the microcontroller here, as well as all the LEDs in the droid. They connect to this microcontroller here. Over here on the left we have 3 motor drivers, one for each motor. These connect directly to the batteries, and then signals from the Bluetooth controller to this chip here cause it to turn the motors on or send them in forwards or reverse. Conclusions, yep, it's an R unit. Alright, great, let's put it back together. Let's take a look at the dome. I feel like there should be more LEDs in the dome. Oh, see, that moves around. If that were to become an LED, yeah, this does come off. Oh, it came apart. There. The pattern that was made in the plastic is kind of interesting. So to make this an LED, I'd have to drill out the back, jam an LED in there, probably 3mm, but then I would also need to drill out the back of this a little bit because the wires are going to need, either the wires will need room to maneuver like that, or I have to glue this in place so it can't be maneuvered so the wires don't get damaged. So what's the right approach? That's up to you. Well, it looks to me like there is a position for a second LED. Only one LED for that little slit that's behind here. So yes, this is there's only 2 LEDs. This deserves a third LED mod. This deserves that to become the third LED. Let's take this apart. See all those springs? Try to not lose those. This is the underside of the connector. The copper pads here, the 5 big ones here, are what those springs and contacts touch against to make a connection to this PCB. The LEDs are labeled R, G, and B. That's the R LED there. The G is in the middle, and the B, you can follow the trace. It goes nowhere. The B LED is not wired up to anything. So that is what we would need to wire that the globe up to. Which actually makes life a little bit easier. I think we can do this mod. We're doing this mod. This mod is happening. I wasn't planning on it, but this mod is going to happen. SK deserves that third LED. I have no sense of how this is going to go. I'm just going to try drilling a small hole into the back. It's very chewy plastic. So what I've learned is that's not really a lens, it's just black plastic in there. I really should go from the front towards the back and find like a bit that's about 3 millimeters and just drill back. That's what I think I need to do. Right, so where are we? I drilled the ball out a little bit, stuck a 5 millimeter LED in from this side. It does not come out the other side. So once I had that fitted right, I pulled the LED back out, filled the insides with hot melt glue, pushed the LED back in. You can see a bunch of hot glue came out the back side here. Scraped a lot of that off. Little bits came out around the edges here. Tried to clean that up as best I can. And now I have an LED in the ball ready to go. This piece here, the back that the ball goes into, I widened that hole a bit. And it's going to be limited in its movement, but it can still move. I'm not going to super glue the thing down. I'm going to let it move a little bit, but it's not going to have a lot of movement to it, but that's okay. What I'm doing right now is, with LEDs, you need a resistor in series with them. The resistor's purpose is to limit current. If you put too much current through an LED, it will burn out. How much current you put through the LED also relates to how bright it's going to be. Now these LEDs, these are super bright LEDs, so they're bright without a lot of current needed. So I have this little box here. This is a resistance substitution box. The idea is you can set which side, this side or this side, you're on. Set your resistance values through these knobs here, and that's what this represents, a resistor at that value. And I have this red wire goes to my bench power supply. It comes through the resistor. It's going to go into the positive side of the LED, and the other side will be going back to the ground on my bench power supply. Now this is a 5-volt supply. Figure about 2 volts forward voltage for the LED. So roughly we're looking at maybe 3 volts of power going into this. Voltage divided by current equals the resistance you want. And I want like 5-ish milliamps. So 0.005 divided by 3 is sort of like 600-ish ohms maybe. So we can just we can start at like 470 here and see what we think about brightness values for this LED here. So let me turn the power supply on. And that's not bad. That's actually, if you look directly at it, because there is some directionality to the LED. If you look directly down the middle of it, it's pretty bright. It might actually be too bright. So keep going through the resistances here, increasing the resistance, and you can see the LED starts to get a little bit dimmer. Now around 2.2K is probably a little bit better, but whoops, I went right to 10 ohms and I just blinded myself. So that's at 4.7K. And that's not bad, and that's probably what I'm going to go with. But I mean, we could go even lower. 6.8K, 10K, 22K, 33K. Now we're getting down to where it's maybe a little too dim. I mean, I'm almost thinking about going at 10K here because I don't want the LED to blast light out. If you notice, the other LEDs aren't really bright. So 10K might actually be the way to go here. I think that's what I'm going to do. I think I'm going to go with a 10 kilo ohm resistor. So I need to find one, and then I need to think about wiring this all up. I've had a thought about that. If we come back and look at this PCB again, there's the 4.3 volts. It's closer to 5. Coming in through here, but that hole there and that hole there, I could solder to either one of those. So I'm going to solder my 4.3 volts to here instead of trying to tap off of it down here. That means that I am not soldering to either of these PCBs, which is what I prefer. And then the other wire will go to here, where the B LED is supposed to get power from, or its path back to ground, actually. So what I need to do now is I need to wire solder two wires to this these LEDs here. Put a resistor in series with that, solder them to here, reassemble, and we should be good to go. I have some 30 gauge wire. It's stranded wire with a silicone insulation, which makes it a very bendy wire. It's okay with taking a lot of twists and turns like that. So I think red will be my power, and since it's going back to the blue line, we'll have a blue wire for the return. That is going to be more than enough wire. I will trim it further as I determine what the length really will be. That's my wire taken care of. I need to go find my resistor now, 10 kilo ohms, and I need to find some shrink wrap as well. So I can't find my box of resistors at the moment. I found my backup box of resistors, which has a bunch of non-standard values in it. This is a 9.1K resistor, or whatever. I want to have wire on either end of that resistor so that there's room for it to bend. I think my first job here is to craft the red wire with the inline resistor. Tin the ends of the wire first. This keeps the stranded wire from fraying while you're working with it. Now I want to put a little heat shrink tubing on this just to help insulate and secure. There we are. 2 layers of heat shrink. We have 2 pieces of the small blue heat shrink covering the joints themselves, and then a larger piece of green heat shrink covering the resistor and the 2 ends to help solidify that connection there so it doesn't come apart anytime soon. There's some rigidity there in that part of the wire, but that's why I have lengths of wire on either side, so either side can wiggle while that place stays rigid. Now what? I think we solder to this PCB, and then we figure out distances. Alright, so there we are. Everything's soldered together. On that side anyways. Now we'll start going through reassembly and figure out some wire lengths. Start to reassemble bits of the dome. I'm just thinking I'm going to have these wires come out through that hole there. That will allow for some form of cable management. The tricky part is getting the heat shrink of the red up. Oh, there we go, good. There we go. It sits like that. That'll be in there like that. So I want to give these some slack about there. All right. I want to now pre-tin these wires. And I hear you saying, you screwed up, and you know what? You are exactly right. I did screw up. This is what I forgot. This needs to go. There. It can move a little bit, not a lot, but it'll work. And as for the excess wire, I mean, we can try tucking it. Shall we? The LED is kind of as I thought it was going to be. It's a bit directional. If you're looking directly at it, it's very bright, but if you look at it off-center a little bit, it looks a little bit darker. Maybe I should have gone with like an opaque, a cloudy, frosted, whatever you want to call it, clear LED of some sort instead of that. And I suppose I could always change it out, but I liked the green. I wanted green because I wanted a color that you don't normally get on a droid. And that worked out okay, I think. Yeah, I think I'm happy with how that came out. So now both of my R units, SK and my R2-D2 unit, both have custom third LEDs now. Of course, now I'm thinking I want to go back and do something to make that brighter, change the resistor or something. But you saw how tiny that LED board is, and it's heat staked. It's pushed into place, and then like kind of like a soldering iron is pressed down on the plastic stakes that it's been sat down upon, and the plastic melts, and that's how it gets secured in place. So to remove that PCB, I'd have to cut those stakes, and then I'd have to, I don't know, glue it back in place later on. It's a hassle. It might not be worth modifying it. I think I might leave it as is. But there you go. That's SK-620 modified with a brand new LED.